Okay, today we're going to be analyzing a game of Angry Birds. So first you kind of have to record the actual game, and yeah, this is start of my game, and that was the whole game for me. So, alright, so first you have to set the origin, which is right here, or right here. It's right there. And you click on the bird when it's pulled back at its farthest. Then you have to start adding some points, which you just go through and go to movie options. Now you're going to want to hit first VA point defines time as 0. You're going to also want to put the movie as 5 frames after adding a new point, because that'll take a lot, it'll make it a lot faster, and the regression line actually adds those points anyway. So you really don't need to add them 1 frame at a time. So then you just go through and add each point. Oh, there's 5 frames. So I added one right here. Then this is 5 frames after. And then 1, 2, 3, 4. Okay, this is 5. Okay, 5 frames, added a point. 1, 2, 3, 4, 5. Added a point. Now when you actually add the points, it's going to jump automatically, but because I'm doing it after, it doesn't do it for me. And then as soon as the bird hits, you don't do any more points. You just do these points. So that's it. You also have to find the scale of the bird, which is around, I think, 0.76, something around there. And when I did that, I got a for this one, which you have to add the graph. And this is the Y position for the bird. But when I added it at this little bird as 0.765, it turned out to be an acceleration of negative 5.5, which is close enough to half of gravity that it's good enough for this. And so yeah. But to add the regression for this one, you have to go function, curve fit, you do the quadratic, you try the fit, looks good, hit OK, and it'll add it. Okay, hold on, gotta delete that one. Alright. Now, you have to add a couple graphs to get these ones, which you just go insert, graph, and it'll add your graph. Also, so then I did one that's an X, one that's a velocity for Y, and one's a velocity for X. So, what you can't see with this one, because fewer points, is that velocity is always changing, whereas for Y. But for X, it doesn't change. It remains constant, because the bird is moving at a constant velocity this way. So your slope's going to be, well, your velocity is going to be constant. And because it's not moving much, the slope will be around 0. Also, for the X, it's obviously going one way. You can just use a linear fit, which is right, the R on it. So if I click on it, then I go that, it'll just add it for me. And it'll tell you all this, which I think, okay, I'm not going to explain that one right there. And this is the velocity. This area shows you everything that goes on for the 4 points that I added. So, should be good. Now, just adding a little bit of calculus into this. This is your position or your displacement, and this is your velocity. So you go from this and then to this. This would be the derivative. So it goes um, position, velocity, and then I think speed or acceleration. Which, if we did a derivative of this, it would turn out to be that. And it would be um, wherever this hits 0 and this one is at a max or min, the derivative will actually be a point of inflection, because for that, it's like you're going up here, it's pulling you down, pulling you down, pulling you down, and then when you hit the point and you're coming back down to Earth, it's changing direction. And that would be your max and min, your point of inflection, and your 0 for everything. Alright, that's it. Thanks for watching.